Hello. You can type in the meeting chat during the class. If you have a question, you can type here. Okay. And to have questions. Okay. And let's start. So before we start, we have a brief review. Okay. So in this review, and we have learned the rotation of a rigid body, right? This is what we are learning. And what we did is given the angular something to find something, right? For example, the angular, there are two things, right? Angular velocity. If we have a scalar, it is the omega, right? We call it is a scalar. And if in vector, it's the omega with a arrowhead, right? And also, if given the angular acceleration, right? Acceleration. And for the angular acceleration, it is alpha, right? If we just have a alpha, it is a scalar, right? Scalar means just a number. If in vector, we just use a alpha with an arrowhead, right? And in vector version. So given these items, and we are required to find out find a specific position, right? Specific position is the position given a position of a specific point, which is let's get the RP, okay, ROP, okay, or in vector is the ROP with a hat, okay, and we require to find the velocity. So velocity is we we are required to find the velocity. Okay, let me make it a little bit smaller, okay, and make sure we have enough space. Okay, so we find this particle's particle velocity, right? Particle's velocity. And it can be VP as a scalar, right? And the velocity of P as a scalar, or it can also be a so if we use a vector method, it can be a VP as a vector, right? And we are also required to find the particle's acceleration. So it has the vector version, right? AP, and the scalar version, right? The scalar version AP and the vector version AP for the vector, right? For the acceleration, there are two components. One is normal acceleration. The other is the tangential acceleration, right? And we need to calculate them one by one. So since there are scalars, right? In blue color, we can use the scalar method to find out the velocity and acceleration, right? So there are scalar method. In scalar method, so velocity p is omega times ROP, right? O is the center. And for the acceleration, we need to consider two aspects, right? And it has a normal acceleration and the tangential acceleration. For normal acceleration, it is about the direction change, right? It's about the direction change. And we can take it as 向心加速度, right? And for the tangential acceleration, is about the speed change, right? The speed change. And we take it as tangential acceleration, which is 切向加速度, right? 切向加速度. So for the normal direction, right? Normal acceleration is an is omega square ROP, right? The tangential acceleration at is just alpha ROP, right? And this is a scalar method. So we also have what we call the vector method, right? Vector method. So in vector method, we just find out the vector for every component and do the cross product, right? So for example, VP, actually we just find the vector omega cross the vector ROP, right? From O to P. And if we want to find n, right? For the acceleration. Acceleration actually has two parts, right? One is normal, the other is tangential. For normal one, it is omega cross v, right? Also equals to negative omega square times ROP. Why here is negative? Because A need to point to the center, right? ROP is from the center to outside. We need to use the opposite, right, direction. Therefore, we need a negative sign here. And AT, right, in the tangential acceleration is alpha across the ROP, which is simple. We just apply these equations to find the result, right? It's not hard. And today we're gonna have such a plan. So okay, today's plan. So firstly, we talk more on the belt drive. And then we talk about the drive ratio. And then, and then the relationship of alpha, omega, A, and the velocity in gear pairs. And then we talk about the relative motions, which is lecture 3. Relative motions actually is about relative velocity. See in lecture 3. Okay, so we just continue from the belt drive on this example. Okay. So a series of small machine components being moved by conveyor belts pass over a radius idler pulley. Okay, 一个传送带. Okay, so many components. Okay, the brown color components moves. At this instant, okay, we know the pulley has a radius of 120 millimeter. Okay, at the instant, the velocity of point A is 300 millimeters. Okay, velocity of point A is 300 millimeter per second to the left, and its acceleration is 180 millimeter to the right, right? To the right. You should know the direction is very important, right? The velocity is to the left, and the acceleration is to the right. Determine the angular velocity and the angular acceleration of the pulley, and then the total acceleration of point B. Okay, point B is for total acceleration. For the wheel is angular acceleration, angular velocity. So how to deal with it? Firstly, we mark the velocity. So for VA, right? VA is 300 millimeter per second along the belt, to the left, right? So this is a VA. VA is 300 millimeter per second to the left. And acceleration of A, acceleration is to the right, right? To the right. We use a black one. Oh, black one is not good. We just use a green one to the right, right? Acceleration is to the right. And we know the acceleration is 180 millimeter per second square. So you can tell apart the velocity and acceleration. You can see the acceleration is something second square, right? And the acceleration is per second, right? So one we square, the other is just a second. Okay. So this is what we know. And based on this, what can we do? We need to talk about the Adler pulley, right? For the pulley, the omega and alpha are all on this wheel, right? Therefore, we need to use the belt information, right, to analyze the wheel. Therefore, there is a critical point we need to use. What is the point? What is the point? With which point we can link up the belt motion and the pulley's motion? Which point? Anyone here? Which point can link up belt motion and the wheel's motion? Point B, all right? Point B. So now point B is marked here. If it's not marked here, you should know point B is very important, okay? Because point B is shared by the belt and the wheel. Therefore, point B is very critical, all right? So, okay, we know point B. And we just find the angular velocity and the angular acceleration based on point B. Firstly, angular velocity. So we know in this wheel, so if we have point O here, right, it's the center, and point B here, and OB is the position of point B, right, position vector from O to B, okay, and you see in this wheel, we have such a relationship, right? So we have VB, velocity of B, equals to omega of the wheel times ROB, right? ROB is given. So what is the VB? What is VB? VB and VA on the same belt, right? Therefore, we have two equations, right? For one thing, VB on the wheel has such an equation. Secondly, VB equals to VA. Can you follow me? Agree with me? Agree with me? Therefore, VA is omega ROB, right? VB is can be replaced by VA, right? Therefore, we can see VA is the omega ROB. So VA, we just substitute 300 millimeter per second is the omega times the ROB 120 millimeter, right? Therefore, what is the omega? Omega is what? 2.5, right? 2.5 reading per second. This is yes, 2.5. This is what I get right directly. And then the angular acceleration. So angular acceleration is about alpha, right? Alpha is it is related to tangential acceleration, right? Therefore, we find the tangential acceleration about B. Tangential acceleration about B. Speed change on B. So what it is? We know tangential acceleration on point B has two possibilities. Possibly, it is tangential to this circle to the left or to the right. So which one is correct? ABT. Which one is correct? Left or right? Left for L, right for R. Which one is correct? ABT's direction. Left or right? Okay, good. ABT's direction is to the right, all right? Because it should be same to that of AA, right? AA is to the right, right? Direction same to that of AA, right? To the right. And we know this magnitude is 180, right? So we can have okay, for the acceleration, we have such an equation. So ABT, okay, ABT is alpha times R, right? Alpha times R, ROB, right? ROB. And then we have another equation is ABT actually is AA, right? Equals to AA for the numerically, right? And then AA is alpha times ROB, right? AA is alpha times ROB. Substitute. So AA is 180 millimeter per second square. Is alpha times 120 millimeter. Therefore, we can get alpha is 1.5, right? 1.5 reading per second square. Okay, that's it. And next one is the total acceleration of point B, right? Total acceleration of point B. How to find it? Total acceleration has two parts. One is ABT, we already have, is 180 millimeter per second, right? 180 millimeter per second square, and this is tangential. So the other is a normal, right? Normal is from point B point to the center, right? Normal is ABN, AB normal. Okay, we just draw a picture here, okay? And this is the left side, and this is the right hand side. Okay, so point B, oh, sorry. Point B is here. This is ABR, right? ABT. ABT is the 180 millimeter per second square. And we need to know ABN, right? To find AB's acceleration, we also need to find ABN. ABN is normal, right? Normal acceleration. ABN actually is easier to find, right? We just substitute the formula. So omega times the ROB, that's it, right? Oh, sorry, omega squared times the ROB. So ABN, we just substitute, is omega squared is 2.5 square, right? ROB is 120, right? Millimeter. So at last we have okay. We because it's not an international unit system. We need some units here, okay, to avoid making mistakes. Omega is 2.5 reading per second, and the square, right? Square. ROB is 120 millimeter. Okay, this is the unit. So at last, it is 2.5 square times 120, right? 120. Actually, it is 750 millimeter per second square, and this is ABN. Okay, ABN. ABN compared to ABT. ABT is here, right? ABN is here. Compared to ABT, is a little bit longer, right? So we need to draw ABN a bit longer, like this, right? More than 3 times, all right? More than 3 times, just here, okay? ABN is much longer than ABT. So this is 750, okay, millimeter per second square, and the ABT is 180. And now we need to find out the total acceleration. What is the total acceleration? It's the vector summation. Okay, it's the vector summation of these two acceleration. We need to draw a rectangle. Rectangle from the end of ABT along ABN, and from the end of ABN along ABT, right? At last, we got such a rectangle, and we need to link up from the very beginning to the end point, right? Diagonal point. So this is AB. Okay, this is AB. So from the triangle, right, we can calculate AB. Actually, AB is ABN square plus ABT square and the square root. This is the result. So we just substitute, right? We just substitute AB actually is ABN is 180, right? And millimeter per second square, and square, right? ABN plus ABT is 750 millimeter per second square, right? And square root. After calculation, we find AB is 771 millimeter per second square. This is the true angular true acceleration of point B, right? 771. That's it. So how to find the angle? If now we are using scalar method, right? What is the angle of AB? We can take a horizontal as the reference, use this angle. This angle is the beta. Actually, we know tangent beta is ABN over ABT. right? Therefore, we have beta is arctangent ABN, sorry, over ABT. Therefore, it's arctangent 750 over 180. So it is 76.5 degree, and this is the angle. So finally, AB is 771 millimeter per second square, and the angle taking horizontal as a reference, this angle is 76.5 degree. That's it. Okay, give you 2 minutes to just and to see whether there are any questions on it. You need to clear about the belt drive to identify the angular acceleration and the acceleration. Also, the acceleration on the belt and the acceleration on the wheel edge. Okay, no question, right? We just move on. Okay. And see. Hey, hello. Any question? No. Okay, so how many percent can you understand for this example? If 100 are gonna be very happy, right? Can be over 80%. It's a number. You can write me a number. Actually, during the past years, I give some online lectures. I always ask you a number, so you can use a number to describe how many did you get. Totally understand is 100, right? Otherwise, it's going to be a number between 0 and 100. You can type such a number. For me, it's 100 because all developed by me myself. Okay. For you, I need you to estimate how many did you get. Okay, if there's no feedback, I just move on. Okay. You're having dinner. Okay, then uh, this is about the belt drive, right? And let's uh, let's see a animation about a belt drive. Okay, so let's start, and I just share my screen to you. And now you can see a SolidWorks. See belt drive here. Okay, so you can see two wheels here, right? And let's look at how it moves. Okay. So if we play, we can see from this animation that you can see it has the green one shows one type of acceleration, and the red one shows the other type of acceleration. For the green one, what is the acceleration? Which is the type for the green one? Do you know? What is the acceleration type for the green one? And what is the red one? All right. Green one is the actually if it moves in the green one can be velocity, right? Can be tangential acceleration, right? The red one is the normal acceleration, right? Red one is normal acceleration. On the pass through the wheel, right? The wheel region, it start to have a normal acceleration. If a point moves in a straight way, right, on the belt between the wheels, there's no normal acceleration, right? You should know about that, right? The normal acceleration just appear in suddenly, right, and disappear suddenly as it leave the wheel, right? Okay, and we just stop share and switch back to the iPad. And then we consider the belt drive, the drive ratio, okay, the drive ratio. So when we consider two gear, okay, two gears, and it move together, and there are connecting or touching teeth, right? A and A prime here, okay, A and A prime here. So there are two gears. One is gear B, the other is gear C. And on the gears, there are 2 points. A is on gear B. Okay, A point A on gear B, and point A prime on gear C. Okay, and we need to know point A and point A prime. Okay, as gear A rotate to the right and gear B rotate to the left, right, in the opposite way, all right, because the teeth should move together. We should know the velocity of gear B, sorry, gear A, point A should be same to the velocity of point A prime, right? These two velocities should totally same direction and the same magnitude. Otherwise, the teeth will be broken, all right? Equals to AA, and otherwise, the teeth will be broken. Broken. Okay, that's it. Therefore, as VA equals to omega omega B RB, all right? VA is on gear B, right? VA is on gear B. Therefore, it is omega B RB. And VA prime is omega C RC, right? Therefore, omega RBE equals to omega C RC. And when we do the ratio, we can have such a expression. You should know the drive ratio formula won't appear in your test paper and examination paper. Okay, you should know drive ratio by yourself. Okay, no need to remember, just understand what happened over there. Okay, and let's see. What about the acceleration? What about the acceleration? Actually, there are two things, and you can see VA equals to VA prime. Similarly, for the acceleration, these 2 points should have same acceleration, right? Otherwise, the velocity cannot be same, right? So actually, the acceleration of A in tangential, right? In tangential, because it moves up and down, right? Tangential is equals to AA prime tangential, right? Which means alpha B RB is alpha C RC. Therefore, we highlight in green, alpha B and alpha C has same ratio as omega B and omega C. Okay. However, the normal acceleration is not same, right? Normal acceleration is not same. Let's analyze. So for normal acceleration, gear B, it is omega B square, right? Omega B square RB. And for gear C, it is omega C square RC, right? Omega C square RC. This is the normal acceleration ratio. Normal acceleration ratio. So it is the AB over AC, right? Is in this ratio. And this ratio also equals to, okay, so omega B square over omega C square actually is RC square over RB square. And RB over RC, we just multiply RB over RC. Actually, we can eliminate, right? So RC eliminate, RB eliminate. Finally, we have the ratio is RC over RB. That's it. Okay, let's see an example. You may want to find the angular velocity of pulley B and pulley C. Okay, B and C. A is a driving belt. B and C is a driven belt. Okay, A drive D, and D and B move together, and B drive C. So on D and B, let me show you what happened here. So for gear B, boy, B for boy. Okay, so it just if we look at it from left hand side. Okay, if your eye is here, okay, and you look to the right, and you find gear B for boy is so large, right? Gear B is here, and you can also see a shaft here. Okay, you can also see a shaft here, and gear D for dog is in front of gear B, in front of gear B. So gear B and gear C, the gear D for dog, are both fixed to this shaft. Okay, so there is a shared shaft. On this shared shaft, they share the same velocity, same omega and same alpha, right? So omega B and omega D are same, okay? Are same. So here we come to the topic. Let's see. To find the angular velocity of pulley B, how to get it? Angular velocity of pulley B. B is equals to D, all right? D is the, okay. Firstly, we find the omega A when T is 3, okay? We just substitute omega A when time is 3 seconds. We just substitute 3 is 20 times 3 plus 40, which is 100 reading per second, right? And now we find omega B. Okay, let me show you how to do it. You need to build a chain of drive ratio. Let's see how to build such a chain. Actually, it's quite easy. So what we know is A, right? What we do not know is B and C. So we take unknown omega B on top. And what we know is omega A. We want to know this ratio. If we know this ratio, we can find omega B, right? Straightforward. So actually, it's quite easy. So omega B, we see where it experiences when from B to A. Actually, B and D, right? Because B and D are a shared shaft. And then from D to A, right? So therefore, omega B can be over omega D, right? And as it's divided by omega D, we need to multiply omega D to do the compensation, right? And then we divide it by omega A here, right? Oh, sorry. Uh, oh yes. So omega B over omega D is 1, right? And the omega D over omega A actually is RA over RD, right? RA over RD, which is 3, right? Which is 3. Therefore, omega B is 3, omega A is 300 radian per second, right? For the belt C, for the pulley C, we do the same thing, right? Because omega C is unknown and omega B is already known, right? So omega C over omega B is RB over RC. Actually, it's just we just find RB is 100, RC is 50, right? Millimeter per millimeter, which is 2, right? So omega C is 2, omega B is 600 reading per second. This is the answer. Any questions?